My screen visible?
Yes.
Okay. So in week 4, I guess if you have seen the lectures, we are just discussing about the polynomial function. In the polynomial function, we just try to like in week 4, we are just going through the different types of a polynomial function and how to generally represent that, or how to plot the graph of a polynomial function. If you've been given the roots, like mostly if you have been, if you are able to take out the roots from the given polynomial that has been given to you, the starting behavior, the end behavior of polynomial. So those are the important concepts to know how to plot that graph. Okay, and after the plotting, we'll be able to know the like basically the degree, so you can directly see from the polynomial itself, maybe the number of turning points that they have, or many other things like the behavior also. How did the function behave? The polynomial is behaving between some domain. Okay, that has been given to you, whether it's an increasing function or decreasing function in the given domain. Okay, so those all things we'll be trying to learn from today's session. So we'll just finish it off. So the basic definition, those are not that important, but okay, that's fine. So based on two types, like first of all, the definition is pretty simple. Like any mathematical expression that consists of n number of mathematical term that has been added together. Okay, so any mathematical expression, that is basically any expression that consists of n different or maybe n mathematical terms. So definition is pretty simple, and the function basically is represented. Anything you can represent. Okay, and for this type of function, if you have been given this type of function, normally if you have not been given anything regarding the domain and the range, basically it is from R to R. Okay, so basically the domain will be R and the range also will be R. Okay, so these are like simple thing. The definition and all, this not be, they'll not be asked regarding the definition and anything, but it's fine. You should be knowing the basic stuffs regarding the polynomial. The next thing is based on like basically based on the number of variables. So this can be divided into two parts based on the number of. These are just the definition. In 5 minutes, I'll just finish the definition part. It's not that important, but yeah, if, as this has been discussed in the lecture, we should be knowing all those things. So based on the number of variables that is available in the polynomial function, okay. So based on the number of variables, it can be divided. Okay, so it can have n number of variables. Like it will start if you have just a one variable. So basically, if you just have a one variable, that means it can be in the form of, let's for example, 5x square plus 2x. Okay, so this is the one variable basically. So you just have x as a variable, right? And then you can have a two variable. So if you have a two variable, that means 5x square and then y. So basically, you have two variables, right? So here from 2xy or something like that. So you have just two variables here, x and y as a two variable. Okay, and then you can have a large variable like for example x, y, z. So here you have three variables, right? Similarly, based on the degree also. Based on the degree also, you can define the function as constant polynomial. you can have a linear polynomial. Basically here the degree will be 0. So any constant function, let's for example y equals to k or something like that. So function is just a k or something. Okay, so that's basically a constant polynomial. Linear polynomial, you would have read about the straight line. Okay, so 2x plus 4. So you just have the degree of the x is 1. Okay, so here the degree is 1. Similarly, a quadratic equation, you would have read about the quadratic also, right? So 2x square plus 4, something like that. Okay, here the degree is 4, the degree is 2, correct? So the degree basically is the exponent that a variable has. Okay, so here the degree is what? Equals to 2. Similarly, you can have a cubic. Okay, so there the degree will be 3. Okay, so it will be somewhat like 2x cube plus some 4 plus 5x square, something like that. Okay, so based on that, so you can divide a polynomial like whether it's having a one variable or two variable or three variable based on the number of variable that is available or in the degree. Okay, so degree basically is the the exponent. So degree can be okay. So I'll just define degree also. So degree of a polynomial is basically the highest degree of any of the term. Okay, that is available. Okay, let's for example you have some x to the power 12 plus x to the power 5. So for this term the degree is 12. Just for this term the degree is 5. But as a whole, as a polynomial, we'll be saying the degree of this whole polynomial will be 12. Okay, so that's basically the highest degree of any of the term. Any one of the term. Okay, so this is what the degree you call it as. So for each term you can tell, so for each variable also you can call it as, like for example you have some x to the power 12, okay, and y. For this term the degree is 13, right? And for this term the degree is 5, but as a whole the degree is 13. Okay, and for this term itself the degree of x, okay, will be 12, and for y it is 1, correct? But as a whole, if you have been asked the degree of the polynomial, this polynomial, the degree will be 13. 12 plus 1. Okay, and we can say that how many variables are there in this? Two variables, right? X and y is the two variables available in this polynomial, correct? Sometimes some of, yeah, some of the definition are also like monomial or binomial. Will not be asked, but just for the sake of knowledge you should be knowing. Okay, if you have a polynomial with only one term, or you have two terms, or you have three terms. Okay, so one term can be some constant function also, or x to the power 16, something like that. So only one term is available. So if you have a two terms, say x to the power 16 plus 10, or if you have a three term, x to the power 16 plus x square plus 15. Okay, so there's just a definition. It will not be asked, but you should be knowing all these things. So till now we have just discussed about the polynomial, and then on the basis of the number of variables can be divided. Maybe the one variable, two, three, four, five, like n variables, and then you have a degree based on the degree of the polynomial. So whatever the degree is, like if you have a some constant function where the degree is not defined, like zero basically, so that is constant function. If you have a straight line equation or a linear equation, so that you call it, because the degree is 1, so you call it as a linear. Similarly for the quadratic the degree is 2, for the cubic the degree is 3. So this is what is, and then you have degree, we have defined the highest number of highest degree of any of the term, like each individual, if you just each individual term will be having some degree, and out of that whichever is the maximum will be the degree of the whole polynomial. And then on the basis of the number of term available in the polynomial, you can just define as a monomial, binomial, and trinomial. Okay, and then you should be knowing about some of the operations. So all these things are very simple. I'll just go fast here. So how do you do the addition of a polynomial? So first thing is some of the operation on polynomial function. Okay, the first thing is the addition. How do you do the addition? Also, so while you're adding two polynomials, you just check out the coefficient, like the coefficient of the same degree. Okay, so let's, for example, I'm just adding one constant, that is, let's, for example, I'm taking a cubic polynomial. So the first polynomial is AQ. Okay, and then the second polynomial I have the coefficient BQX. Let's, for example, it's like B4X4 also. Then B square X square, then B1 X1, and then B0 X2. Okay, if I have to add both these equation, we'll just arrange this in the like the polynomial that has been given to you. Just put it in some of like the decreasing form for the degree. Okay, so if we have basically the only one, the variable is only one for this polynomial, the only the variable is x. For this second polynomial also, the variable is x only, in both the cases the x. You can just arrange it in the decreasing value of the degree. So you can see that here the degree is 3 for this term, here the degree is 2 for this term, 1 for this term, and 0 for this term. Similarly, we have arranged this also in the decreasing order. Okay, so here the degree is 4 for this term, 3 for this term, 2, 1, and 0. So if you just have to add, you just take out. So for wherever the degree is same, you'll just be adding the coefficient. Okay, so here the degree is 3, 3 for both the thing. Okay, so you'll just add the coefficient AQ plus BQ, B3, sorry, and then x to the power q. Similarly, for this case, as you don't have anything in the polynomial 1, so you just take out as a 0 as a coefficient for that particular, like for x to the power 4 degree, you'll just take coefficient as 0. Okay, so you'll just be adding something like 0 plus bit of 4 and then x4. Similarly, for this case also, because you just have to, whenever you are adding n number of polynomial also, just check out the degree. Okay, so wherever the degree is same for that particular variable. Okay, for example, here for this x square, for this x, you can see that the degree is 2, right? So now you can add the coefficient, so x2 plus b2. Similarly, you can do for all the other cases also. So this is pretty simple, and the same thing. So here also 0, 1, basically 1 plus b0 dot x0. Okay, so this is how you do for x0 is basically this constant only, 1 plus b0. So, and the same thing you'll be doing for the subtraction also. So for the subtraction also, just take out wherever the two polynomials, whatever has been given to you. So just take out the variable with the same degree, and then you'll be adding the coefficient or subtracting whatever has been given to you. Okay, is it clear to everyone? So if I'm
Yes,
just
sir.
asking, just have given qx equals to minus 3x square plus 2x minus 2, and then you have been given px as x cube plus 2x square plus 8x. And if I'm asking you px minus qx, so what should be the value? What should be the, so can you give me the polynomial?
X cube plus 5x square plus 2x plus 2.
X cube plus 5x square plus 6x.
2, 6. Sir, is it 4x?
8x.
Yes,
8x.
Yes. Okay, I think it's 2x.
Minus 5x square, no? Minus 1x square.
Minus plus.
Okay, so I'll just put it. Okay, so I guess this should be the answer, but if we haven't got, so let's do it. So x cube plus, because we have to subtract qx from the px, so I'll be writing px as a first. So 2x square plus 8x, correct? And then you have to subtract what? So minus 3x square here. Okay, and then you have plus 2x here, and then minus 2. Okay, so if you are just subtracting, so we'll be just writing as x cube minus 0. So you don't have anything here, right? So if you don't have anything, you'll just be writing 1 minus 0 x cube, correct? And then you have the coefficient, like the degrees x, for the variable x square, that you can see that for the coefficient. So 2 minus of minus 3. So this will be 2 minus of minus 3, correct? So this will be 5x square. Similarly, for x also 8 minus 2, okay? And then basically we'll have to write 0 minus minus 2, correct? So we'll be getting x cube plus 5x square plus 6x plus 2. Is this clear to everyone? It's pretty simple,
Yes.
right? Okay.
Can we add if the variable or different x square, both the p and q, if the variable different, if the p having only one variable, q having two variable, can we add?
No, you can't add. If you have a equation something like q1x equals to like x square plus x, and then you have rx as y plus yx, something like that. You can't add it. Like you can add it, but you'll have to write it individually. Like the summation of these two will be x square plus x plus yx. So basically, wherever the variable is same and the degree is same, then only you can add the coefficient. Okay, otherwise you can't. Okay,
But we can do multiplication and division.
you can multiplication and division you can do. Correct.
Okay.
So multiplication. Okay, let's move to the multiplication part. Okay. So for the multiplication, it's like you just have to multiply each of the term of the first polynomial to the each of the term of the second polynomial. So let's start with a simple example: x square plus x, and you have to multiply with this x square plus 2x plus 1. See, for the multiplication, you just have to just take out as this first term of this polynomial, and then you have to multiply with each of the term of the second. So here you don't have to worry about the degree of the coefficient, like the degree of each term of the polynomial, because in the addition and subtraction you have to worry about the degree or the like the variable also. If you have only xy as a variable, even though the degree is 2, you can't add it to x square. See, so if you have to add xy and directly to the x square, you can't, because as the degree is 2 for both the cases, but the variable is different. So you can add it, but you can't add the coefficient of this two. Okay, this is what I'm saying. But for the multiplication, you can do you can multiply each of the term with the polynomial or the other each of the term of the different polynomial. So for this equation, let's for example this is bx and this is r. Okay, so if you have to multiply, you will be multiplying. In the addition, you will just doing the coefficient, adding the coefficient of this x square and this x square. But here for the multiplication, you will be adding x. You will multiplying x square to each of the term. So x square plus 2x plus 1. Okay. Similarly, you will be multiplying this x to each of the term. So x to the x square plus 2x plus 1. Similarly, for 1 also, x square plus 2x plus 1. Okay. So, and then you can write it as like you can just write it as x to the power 4 and then 2x cube plus x square. Similarly, here also x cube plus 2x square and then plus x. Here also x square plus 2x plus 1. And just to simplify this, you'll be doing the addition, right? And then you'll be checking out the degrees of each of the variable. Like for this x, you can see that x to the power 4, you don't have any other term with x to the power 4 as a degree. So I'll just putting x to the power 4 here. And for this x cube, you can see that here also x cube. So the coefficient, you can just add the coefficient directly. So basically this is 2 plus 1 and then you don't have anything. So you can add it as. And then for x square also, you can just see that this is 1 plus this is 2 and then again you have 1, correct? And similarly for the x as a variable and the degree as a 1, you'll just add it as 1 plus 2 and then for the constant as 1. So this will be the multiplication of this basically px and rx. Okay.
Okay.
Let's move to the division part, and I guess multiplication is also simple. You just have to like multiply with each of the term for the first equation to the other term, and then in the end you just simplify it in the basis of subtraction or like addition or subtraction on the basis of the degree of the term that is available on those cases. For the division, of polynomial, So I'll just give you an example. So here, with the help of x square, we'll just try to divide it, and then whatever the method that we'll be using, you can use it for any other cases also. If this is the divisor, so basically this you call it as a divisor, right? And then the term that you are dividing is the dividend. So basically, let's say example, this is x to the power 4, 2x square plus 3x plus 2. This is what you are dividing, and whatever the term that will be getting here will be the quotient. So this is basically the dividend. This is the quotient, and the remainder in the end you will be getting as a like that will be left. Okay. So the first thing is we'll have to remove each of the terms. So if you are dividing this Rx with the Px, okay. So for the first thing that you'll be doing, so here you have just taken it. So here also in the divisor you'll be just putting your equation in such a way, like in the decreasing form of your degree. Okay, if this is the one variable, let's for example, for our case it is an x variable, so we have written in the form of a decreasing order of the degree. So you can see that 2, 1, 6. Similarly for the dividend also, you can just write it in the decreasing form of the degree. Okay, each for the each term. And now we have to remove each term. Like for this term, we'll just be removing x to the 4 and then x square, then x. So this is how we'll be going. So the first thing that we'll be doing is, you can see that for a divisor of power like a degree x square, if you have to just cut this out, x to the power 4, okay, so you'll be multiplying something with what? X to the power 4, correct? Sorry, x to the power x square, basically the degree 2. So here the degree is 2, here is 4. So you have to multiply something here to just cut it out. So you'll be multiplying with what? To the degree 2, correct? So let's, for example, I'm just writing here the quotient here. So for the first term, if I'm writing x square, because you can see that if we multiply x square and x square, we'll be getting x to the power 4, and then we'll be cut it out. So the same thing that we do in the division, like in the normal maths also. So here also x square, because we just taken out to just put it as x to the power 4. So the first term we have multiplied. Then again, this as we have taken x square, so we'll just be multiplying the whole divisor to the x square. We can't do it just for the one term. Okay, then x square, and then we are getting x to the 4. And then if we are multiplying x and x square, then we'll be getting what? I guess x cube you'll be getting, right? You'll be getting x cube, and then you have basically x square. Okay, and if you'll just cut it out, so this got cancelled out, and then you're left with what? You'll be left with, because you don't have any term in x cube, so you'll just writing as x to the power minus cube, and then you have 2x square, and then here it is minus 1, so we'll be writing as 2 minus 1 x square, correct? And then you can write it off this directly. So the same like the division that you basically do in the maths also. Are you able to understand that? Is it visible,
Yes.
audible? Okay. Yes, sir. Okay. So now for the next term, what should I write it here? Because I have to cut it minus x cube. So what should I write it here? Minus x. Yeah, minus x. Correct. So if I just multiply x square to the minus x, I'll be getting minus x cube, because I should be in every step I should be cutting down the for this polynomial, for the polynomial that is a dividend, we're just cutting out the term with the maximum like the most maximum degree. Okay, so for this case, x cube is having the maximum, like the degree as a 3. So we'll be just trying to remove this. So to remove this, we'll be just multiplying with minus x, and then we'll be remaining with, like, we're left with minus x cube, and then if you just multiply, will be minus x square, and then minus x. Correct. So now this is not remaining, and then we have plus and then plus. So here also 1x square will be left with 2x square. Correct. And then you have plus 4x, and you can just take it out the constant 2. So now what should I multiply? I guess to remove this term, you just have to multiply with 2. So one constant here, 2. So if you just multiply it out, so you'll be left with 2x square plus 2x plus 2. So now if you'll see that this got cut down, and then this 2x is remaining, and then this is also removed. Now you can't do, because you can't just multiply with any non-natural number here. Okay, so you'll have to, you can't, from x square you can't go to x. You can go to, but that will be like a different, like maybe a rational, like not rational number I'm saying. a number that will not be a natural. Like you can multiply it 1 upon 2, x to the power 1 upon 2, but that is not allowed here. Okay, so we'll be left with this term. So this is the remainder for you, and then this is the divisor that you have, and then this is the dividend that you have. Okay, so if you have to write this equation, px upon qx, correct? So you're left with what? I guess you have x square minus x plus 2, but you have some remainder also, so 2x upon x square plus x plus 1. This is how basically you write the equation, correct?
Correct.
Okay, so this is also simple. The division part. Yeah, yeah. Go ahead. Okay, okay. So if you just want to, so you can just do it out. One equation that I'm giving to divide: x to the power 5 minus 4x to the power 4 plus 3x cube plus 3x square minus 4. You have to divide it with x minus 2 power less square. And then the options that has been given to you is x cube plus x plus 1 . You can just try it out.
Option D, sir.
Option B. I guess D. None of the options are correct, I guess.
Option B, sir.
Sorry. Option B.
Sir, it's either B or D.
Okay. Okay, so option B is correct. Yeah. So. Okay.
I
This was
see where
also,
I went wrong.
yeah. So from the number of terms also, you can get an idea, but XQ you'll not be able to. So the first term is being given same. From the second term, you can just get an idea. Maybe B and D. So whichever is correct, right? But to get the final version, you'll have to divide it. I'll just do it quickly, so it don't take. So x minus 2 ka whole square is basically x square minus 4x plus 4, and then you have to divide this term as to the power x to the power 5 minus 4x 4 plus 3x square plus 3x square, sorry, 3x cube plus minus 4. Okay, so the first thing that we'll be getting is x cube. So if you're just putting at x cube, so this will be minus x power plus 4x to the 4 minus 4x cube. So you'll be left with what? You will be left with sorry. I guess this correct. Okay, I've written it incorrect. Are you able to see this thing? Yeah. I guess it's visible, right?
Yes, sir.
Yes.
Okay. So if you'll just write it as, so you'll be left with x to the power 5 minus 4x to the 4 plus 4x cube. We'll just take it as minus plus minus. So this both will get cut down, right? So you'll be left with minus x cube plus 3x square. If you'll just multiply minus x, okay, we'll be left with minus x cube plus 4x square minus 4x. So now if we'll do this, we'll be left with what? Minus x square plus 4x or minus 4. Now you can take it what? You can take it minus 1, and then you'll be left with x square plus 4x minus 4. So this is what we should be getting, x cube minus x. minus 1. So the second statement is correct. Okay, one more question that I'm giving to you. So you'll have to tell me what should we subtract, like what to be subtracted from the polynomial px. So what should I subtract from this polynomial to make it as a divisible by 2x square plus x minus 1? Can somebody tell me what should I subtract? Like as a in the form of a divisor, dividend, quotient, remainder. What should I
Remainder.
subtract? Remainder. Correct.
Remainder.
So okay. So if you have been given questions such that like what should we subtract from this polynomial to make it as a divisible, just write out and calculate the remainder. Okay, if you are calculating the remainder, you'll be done. So I don't think so that will require much effort. So just have to divide it, and whatever the remainder that will be getting, that you have to subtract it from the polynomial px. Okay. Okay. So some other questions I'm just thinking. If you are just dividing a polynomial px with another polynomial qx, you are getting something as hx, and maybe the remainder also.
Sir, can you explain the last question?
Okay, so the last question. Okay, I'll just explain it. So the question was, you'll have to subtract something from here. So if you are just dividing, let's for example, you have been given, you are dividing 19 to 6, and you have been told that what should be the value that you should be subtracting from 19 to make 6 as a divisible. So the list minimum. So the remainder that you are getting, right? So if you're just dividing this 6 with a 19, will be the remainder will be 1. And if you are subtracting this 1 from here, that will be 18. And then you can basically divide it, right? Totally. So for this equation also, they're asking that what should I subtract from this? So that will be divisible by 2x square plus x plus minus 1. So that the remainder, if you are just, whatever the remainder that you are getting, if you just subtract it,
Minus
then
2.
this number will be totally divided by 2x
Same
square plus.
minus 2.
Correct? Is it clear, or should I calculate the whole thing?
No.
It's minus 3.
What is the answer?
6x minus 3, sir.
So, I guess this should be 4x minus 3. Maybe,
Yes, 4x
4x minus
3.
yeah, 4x minus 3. Yeah, so this is basically 4x minus 3 is the remainder. That is should be subtracting from this polynomial to make it as a like divisible by 2x square plus x minus 1. Now the other question is, if I am giving you that a polynomial px is we are just dividing this px with qx. Okay, this is the question. And if you're just dividing px with qx and you're getting hx as a quotient, and then you have a remainder also. Okay, some remainder also you are getting rx. Okay, I'm just writing it as a remainder. Even though this is not the correct way, so whatever the question that you have got, and then rx upon qx should be there. So I'm asking what should be the maximum degree of this Rx? What can be the maximum degree for this Rx? If you're just dividing this polynomial Px upon Qx, and the degree is basically, let's for whatever the degree it is, let's for example, n is the degree for this Px. What can be the maximum degree of Rx?
n.
It is constant. 0.
No. So for this example, if you're just dividing, that the degree was 1, right? So this was a normal case. I'm just asking for the extreme case. You just think of
Degree of
N minus 1.
N minus 1.
0.
N minus 1.
N.
N minus
correct.
n minus 1.
Yeah, n minus 1 should be the maximum degree. Okay, if the degree of this polynomial is n, then for the Rx, it should be the maximum degree would be n minus 1. Correct? How many of you are able to understand this?
No, I don't understand.
Okay. Just tell me, if we are dividing this polynomial px and qx, okay, what can be the maximum degree for this qx that you can divide it this px?
Less than or equal to n.
Less than equal to the same px.
Equal to the same.
correct? So if this is n, this should be less than equals to n, right?
Yes, sir.
It
Yes,
can
sir.
be n also, no?
Less than equals to, I'm saying. Less than equal to.
Yes, sir.
Equal to or less than, correct?
Yes.
Yes.
Yeah. So this
Okay.
will be less than equals to n, correct? Because if you have just n and if you're just putting n plus 1, then you can
Not
get
possible.
it again in the form of some non-natural number, like maybe in the form of 1 upon 2 or something. Some p upon q form you'll be getting where, okay, some fractional number you'll be getting if you're just putting qx as a more than n. There also you'll be getting, but in the form of fraction. But that we are
Yes.
not dealing. We are just dealing with the polynomial which have a exponent as a natural number. Okay. So here also, if you're just dividing px and qx, the qx should be less than equals to n if you have a n as a degree of px. Okay.
Yes.
And then, okay, can somebody tell me why the rx should be n minus 1?
Because we can't divide remainder. That's why it's remainder.
Correct. It should be at least 1 less than that, right? Because if you're just putting n as a any if you're just putting rx as a degree of n and then you're
It
dividing
could
with
still be
something
divided, sir.
with a degree n only, so you can divide it, right?
Yes.
Right? At least, yeah. So any terms as you are taking in the divisor and dividend, here it is the dividend and this is the divisor. And if the maximum, like the degree for this polynomial is n, so this x to the power n, and if you are dividing something with x to the power n only, right? So let's, for example, I'm just taking the remainder also as a x to the power n only. Okay, so that you can divide it, right? You can multiply something and then you can just cut it out. So this can't be x to the power n. So that must be n minus 1, right? And if that is n minus 1, and then you are not able to cut it out. But if that can be a possibility. So that's why the remainder will be having the degree, that degree can't be n. So it will be less than that. So whatever, if the qx has a degree of n, so basically I will just, so the degree of qx should be n, and then this should be n minus 1. Okay.
The remainder.
So, yeah, correct. So for the remainder, so the degree of the maximum possible degree, so degree for this Rx. Okay, so the maximum will be basically the degree for this qx minus 1. Whatever the degree for the qx is given, minus 1. Okay, so with whom you are dividing? It's not about the dividend. So with whom you are dividing? So divisor. So basically, if the here it is n, then the degree would be n minus 1 for the remainder. So maximum, I'm saying this can be anything, but the maximum that you can get is n minus 1. Is it clear?
Yes.
You can't get n as a degree for the remainder. Okay.
Yes.
So if I'm giving you, so for the same case, I'm just giving you some options. So the given is if the degree for this px is less than the degree for qx, then you have to choose the options. Okay, one of the options. The first thing is choose the correct option. Statement. So hx equals to 0 can occur.
How can
Second
we
is,
divide it? How can we divide it if px degree is less than qx?
no, this is what I'm asking. If you have been given something like that, which of the options can be correct?
Okay.
Okay, the third option is
Second option.
what do you think? Which options are correct? First, second, third. You are able to see that, right? The first thing is saying that the quotient itself is 0. Okay, if you are dividing something with a higher degree, the quotient will be 0, and then the remainder is same as the px. So whatever you are dividing, that will be your remainder, or your so the degree of the remainder or the polynomial will be same, or the degree of the remainder and the quotient will be same, or the degree of the hx. So whatever the
First
quotient that you are
option.
getting, which one? So
First
many
option.
of the options can be correct. So basically here two options are correct. Okay, I'm just giving the
First
hint
and
also.
fourth.
First and fourth.
Correct. So the first and fourth is correct. So how many of you are able to understand this? So if you are dividing something which has a your divisor basically, so with whom you are dividing has a higher degree, okay, then what can be the possibility? This is what has been asked here. Okay, so your divisor basically has a higher degree than the dividend. Okay, so for this case, I already told you will not be able to divide it. So if you have a degree higher, then the only possibility is that if you are just dividing x square to x5, that means what? So this can work as you directly as a remainder directly, right? So the degree for this x squared, so for the degree will be same, right? For the remainder and for the polynomial, whatever is been given, the dividend. Yeah. Okay, and your divisor, so basically if you just go and divide it x to the 4 to x cube, x square, your quotient will not be able to. So your quotient basically is what? 0, right? So this has been given. So hx is 0. Okay, so here I written, right? Hx is basically your quotient, and then rx is a remainder. So for the degree for the remainder, for the degree for the remainder and for the polynomial that has been given, or the dividend will be same. Correct? Is this clear to everyone?
Yes, sir.
Yes,
Sir, doubt, sir.
Okay. Go ahead.
Sir, px by qx equal to hx plus r of x by qx is how the r of x it become n minus 1, sir. Ante with show me a small example, please, sir.
Okay. So what I was saying is, if you are just dividing some polynomial, right, px upon qx, and what I said is, what can be the maximum degree for the remainder? Okay, if you are dividing x to the power 5 to, let's for example, x to the power 5 only. Okay, and there are some other values also. If you have for some constant plus b, and then you are dividing with x to the power 4 and then x square, something you are dividing. So the maximum term here is 5. So whenever you will divide it with this term, okay, this is that like this, you will be able to remove this x to the 5, right? Correct. So if you are just dividing something, some polynomial with the degree 5, and here also in the divisor also you have a polynomial with degree 5, and then we have been asked to divide this dividend to the divisor. So this term will be able to remove it. Correct. Maybe there is a possibility that after that will not be able to remove the x to the 4. Correct. So then in the remainder that will be getting, so maximum degree that you can get it off in the form of x to the 4, right? Because you can't get x to the power 5 as a remainder, because if you are getting x to the 5, that means you haven't divided correctly. Correct. If let's for example, if you are dividing any polynomial with the degree 5, and you are dividing with x to the power 5 only, you can't get the remainder as x to the power 5. You should be getting maximum, like you can get anything, but you can't get x to the power 5 for sure. Is this clear? Because if you are just getting, like, you'll be able to cut it out, right? You'll be just multiplying something to just remove this x to the power 5. And after that, maybe there is a possibility that you'll not be able to cut this x to the power 4. Okay, there's a possibility. Correct?
Correct.
So you can get the remainder as x to the power 4, like one less than the polynomial, like the polynomial, the divisor degree. But you can't get same as the divisor. Okay, so you'll be getting at least like one less than the divisor for sure. Is this clear now, or you want me to explain it?
Yeah.
Yes, sir. Yes, sir.
Sir, could you please explain the previous question? This
Okay, so the previous question was, I'm just giving you an example. If you are just dividing some polynomial x to the power a x to the 5 plus b x to the 4, something like that, to your the degree for the qx. So the denominator part has a degree more than the numerator part. So here it would be x to the power 6, let's for example, and then you have x to the power 5, something like that. And if you have to divide this one, you already know that you can't divide this, right? You should be having the numerator part as a higher degree. If you have a numerator as a lesser degree, that means this you can think of as a remainder directly, because you would have done something and then you got this remainder, because you remainder whatever you are getting in the end, the remainder that you can't divide, right, with the divisor. Okay, so here also if you
Got
just
it, sir.
divide this, yeah, so you'll be getting the quotient as a 0 because you can't divide it, so you'll be getting the quotient as a 0, but this can work as a remainder directly. So the degree for this, whatever the given polynomial has been given to you, the degree for the remainder also can be same. So this is what has been asked, and this is correct. So the first and the fourth. Is this clear?
Yes.
Yes.
Let's move to the next part. So
Sir, I have doubt in week 3 assignment.
week 3 assignment. Week 3 is already done, right? So
Sorry, week 4, week 4.
we'll just go through after finishing all these things, and then we'll discuss some of the doubts. Okay, even though we have some 3 more
Sir,
sessions to do. Yeah.
मल्टीप्लिकेशन में ना आई सॉ सम एक्टिविटी लाइक एक्टिविटी असाइनमेंट्स उसमें ना ऐसा हो रहा है कि बहुत ज्यादा टर्म्स है एंड दे हैव वेरी लार्ज डिग्रीज सो अल्टीमेटली कैलकुलेशन एरर हो रहे हैं मल्टीप्लिकेशन ऑफ पॉलिनोमियल सो लाइक इज देयर एनी अदर वे टू डू दैट
No, there is no other way that to do the multiplication, but in the exams and all, they'll not be asking that. I can assure you that there will be a large number and then you have to multiply. Okay, if they are asking a multiplication, maximum 2-3 terms will be there. Okay,
okay.
so 2-3 terms से ज़्यादा नहीं होंगे, so you don't have to worry about that. Maybe for the practice they have given in the activity or the practice, just for the practice, so that you'll be familiar with those concepts. Okay, nothing there.
ठीक है, thank you.
Okay, so we'll go through the activity question. After this, we'll just finish it off, even though we have some more sessions also. So Sunday also you have, and then Tuesday and then Wednesday. Okay, so our first focus is just finish all the concepts of the week forward, and then we'll go through the activity question. Just 1 minute, I'll just take water. Okay. So one more question I'm giving to you. This will be the last one, and then we'll just go through the graphing of the polynomial. So the question is, you have been given 2 polynomials. So the polynomial that has been given to you is x cube plus x square plus 5x plus 7. And then the other question that has been given to you is x cube plus 2x square plus 3x plus 2a. And you are dividing both the term with x minus 2, and here also you are dividing with x minus 2. And the remainder that you are getting for both the cases are same. Then you have to tell me the value of a. This you have to calculate. So the question is, so for both the polynomial px and qx, whatever it is, x cube plus x square plus 5x plus 7, you are dividing with x minus 2, and here also you are dividing with x minus 2. The remainder that you are getting in both the cases are same. Okay, so what should be the value of a? Can somebody tell me what should you do, like the step, if you are dividing something and then you are getting the remainder, because you can't calculate it.
Just equate the both remainders.
So
Yes,
we
sir.
have to multiply it with the divisor.
Multiply with the divisor. Multiply with the divisor. Okay. Okay. Then, but you can't multiply directly. Like you are getting some remainder also, correct? So basically, the remainder is same. So if you are dividing x minus 2, okay, the remainder is same.
Multiplying remainder with the quotient.
7, sir. Substituting x is equals to 2.
Correct. Nice. Very nice. Yeah. So if you just put x equals to 2 for both the cases, the remainder that we'll be getting would be same, right? If you're just putting x equals to 2 in both the equations. Correct? Or not? If the polynomial is having the same remainder, like if you're dividing with x minus 2, correct? So if you just substitute x equals to 2 for both the equation, we'll be getting the same value.
Sir, but when x is 2, the denominator
becomes 0 and the whole equation becomes 0.
No. X equals to 2, you have to put it in this polynomial, right? With whom you are dividing, right? You're not getting. This is your dividend that you were dividing with. This is the px, the numerator part only, and for this also this qx is the numerator part only. So whatever the, if you'll just put it as p2, okay, so after dividing we'll be getting some remainder you are and similarly for qx also, q2 also, you'll be getting the same value. Okay, if you'll just put x equals to 2, what should be the value of the polynomial? Px will be left with
4a plus 25.
4a plus 25. Similarly for qx, what should be the value?
2a plus 22.
2a plus 22. So you are left with 2a equals to minus 3. A equals to minus 1 by 5.
3 by 2, yes, minus 3.
Correct?
Yes, sir. So can I just know once more, how did the 2 come? Like, why we taking 2 here?
How you are taking? Okay, you are putting 2. Okay.
Yeah,
So,
why are we using 2 here?
Yeah. So if you'll just divide it also, right? So if, let's for example, if you are dividing something that is totally divisible by that. So if you have something that, for let's for example, you have a polynomial px, correct? And if you are dividing with something, some divisor x minus 2, and the information given was it was totally divisible by this term. So then what does that mean? If you're just putting that 2 there, you'll be getting 0 as a remainder, right?
Yes. Got it.
So the remaining part will be the remainder.
Thank you.
Okay. So, okay, let's move to the next part, and that is basically the how will you plot the polynomial function. Okay, maybe with one example I'll tell you. We'll just deal with the turning point, and that is the most important part. For I'll tell you, if you are just able to understand those parts, the 2 questions that will be given in your exam will be able to solve it as. So at least for the minimum, you should be knowing the how to, for the given polynomial. If you have been given some, if you have been given for the given polynomial, you'll have to plot the graph. Maybe they'll ask you the end behavior, starting behavior, how many like what's the multiplicity of any of the root, is it odd, is it even? Okay, those type of questions they can ask you. Maybe the number of turning point, what can be the maximum number of turning point, what can be the maximum degree, like degree though you can directly see and tell. But they are the questions that generally, if you just go through the previous term also questions, these are questions that they generally ask in the exam. Okay, let's move to the characteristic of a polynomial function. Some of the character are so see, the only thing that you should be checking is, even though I won't certain that right as correct. So the only thing that you should be checking, if so, for the first type of questions can be, they can give you some form of a graph directly and can ask you about whether the given graph is a polynomial or how many of them is a polynomial basically. So you'll have to just check the break, like if the function itself is not breaking at any particular point, right? Let's for example, you will have a given polynomial as something like this, and then this, something like that, or maybe like this. So this is not a polynomial because it's a breaking. The function itself is breaking. So that should be very smooth. Okay, and there should not be any break in the polynomial function. Okay, curve with no, and that basically you call it as a continuous function also, right? You basically call it as a continuous function also whenever there is no break. That continuity and differentiability will learn in the later weeks. But as of now, you can just think of as there should not be any, that the function should be very smooth and continuous for any function to be a polynomial. But even though this word itself is like very confusing, the smooth and the continuous. Okay, with some example, maybe we'll get to know about that. Okay, so okay, I'll just deal with one with one example, we'll be able to solve all the zeros function, and then we'll learn how to plot everything and all. So let's write the equation first of all, and then we'll see. Okay, so this is the polynomial, and we'll just go through each and every thing about the starting behavior, end behavior, roots, multiplicity, all the behaviors of the polynomial, how to plot this. We'll just learn from this example itself. So the first thing that you should be knowing is, for the given polynomial, to plot it, the first thing is, what are the root and what are the multiplicity of the function? Okay. So for this polynomial that has been given to you, how many roots are there? How many distinct roots are there? So root, you can just count it as 2 plus 1 plus 2 plus 3. But how many distinct roots are there? Different roots are 4, correct? So that is basically 1, 3, minus 5. So these are the roots that you have, the distinct root basically. So this is the repeated root. So 1 is occurring 2 times, and then 3 is occurring only 1 times, as the multiplicity is 1. And basically the multiplicity for each root is the number of times that is occurring. So for this x equals to 1, the repeated root is twice, right? So x equals to 1 and 1 itself. So for this x equals to 3, it's occurring as only 1 time. So the multiplicity is 1. For this case, minus 5 is occurring twice. So you can see that it is occurring twice. And minus 7 is occurring thrice. So this is minus 7. Okay. So multiplicity also you have now you are familiar. So the number of time for this case it is 1. So sorry, the root is 1, 3, minus 5, minus 7. Multiplicity is what? For this case, what is the multiplicity for root 1? So how many times this root 1 is occurring? So you can just take it out from here itself. 2, right? 2. Here it is 1. Here it is 2. And then 3. Correct. Now the next thing that you should be knowing, to plot any graph, like whatever the polynomial that has been given to you, after getting the root and the multiplicity directly you can just, so see, sometimes what they can do is they can't give you direct the polynomial like this. Okay, they can give you something like in the form of like maybe a quadratic equation, then again equation in the form of a linear, then again quadratic equation. So you have to simplify that to just know about the to know the multiplicity and the root, exact root. So if they can give you in the form of a quadratic equation that you have to solve, okay, to write it in the form of a linear, so that you can directly point it out the root for that equation. Okay, so they can't, maybe they can give you in this form also, but they can give you in this form also. Okay, so you have to summarize that and then get to know about the root and the multiplicity of the given function. Okay, to just plot that graph. The third thing that you should be knowing, after getting the roots and the multiplicity, how did the function behave? If I'm just, how did the function behave whenever, like from the starting infinite to the like the minus infinite to basically infinite? So for any type of a polynomial, basically you start with minus infinite, right? And then you go till infinite. If you have to plot any polynomial, you start with minus infinite and go till infinite. So there should be some information. How does this starts? How from minus infinite? How does it start and how does it go till infinite? Correct. This information you should be having. Okay. Is this? Are you able to understand this? End or the starting?
Yes.
Okay.
Yes.
Okay. So what I'm saying is, whenever you're plotting a polynomial, you should be knowing how the function, how the graph of this polynomial will start at minus infinite and how will it go to minus, like positive infinite. If this is clear, let's move to the next part. Okay. So the first thing is, if I'm putting for this given polynomial to get the starting behavior of a function or the end behavior. So to get the starting behavior of a function, so you'll have to check that how does the function behaves when it starts. So it starts from minus infinite, right? If it's starting, if whenever the x was tending to minus infinite, what is the polynomial function value? Okay. Similarly, for whenever the x is tending to infinite, what is the function? How does the function is behaving? Whether the function is tending towards 0, whether the function is tending to an infinite, minus infinite, how does the function behave? So for this equation that has been given to you, can somebody tell me if I'm putting x equals to minus infinite in this polynomial, what should be the value of the polynomial at that particular point? Are you able to hear me or not?
Yes,
Yeah.
sir.
Okay.
Sir.
Infinity, sir. Infinity.
Infinite. So, okay, I'll just tell you. See, in the lectures, maybe all the things have been written. You can remember that, but it's no point of remembering. You can just think of whenever. So I'll just write it out. All the possible values that can happen. Okay.
I think plus infinite.
Okay. So
It's
for
both
this case,
actually. If it is going minus infinity, it can go from the positive also. It can go from the negative also.
okay. Let's deal with
Even
this.
or
Okay.
odd degree.
Yeah, even in order. So for this polynomial, what's the number, like the degree for this polynomial? If is it even or odd? You can add the multiplicity, right? 2 plus 1 plus 2 plus 3. This is 5 plus 3. That is basically a odd, even number. Even. 8, correct? So the degree is 8.
Yes, sir.
So the two things that you should be knowing is the coefficient of the maximum degree. So here the degree of this polynomial would be x to the power 8, right? If you just do the simplification, we'll just expand this whole polynomial. You'll be remaining with x to the power 8 as the maximum degree that is possible for this polynomial. And you will have to check the coefficient. Okay. And if you know about the coefficient, you can tell us about the starting behavior and the end behavior for this polynomial.
Yes,
Okay.
sir.
So for this polynomial, you can see that x to the power 8 would be the maximum degree that is possible for this polynomial. What can be the coefficient for x to the power 8? Can you tell me? So for this case, you can see that each of the term, here also x square has a coefficient as a positive. Here also a
1.
positive, here also positive and positive. That means the positive, and that basically is 1 here itself. But you don't have to worry about the exact value, but whether it's a positive and negative. If that
Positive
is
or
a
negative.
positive, yeah, correct. If you are able to know that much, whether it's a positive and negative coefficient and the degree for the the maximum power, or you can maximum order of any of the variable, like the variable that is present, the degree for that polynomial, if you are able to know, and the coefficient, you are good to go to know about the starting behavior and ending behavior.
Yes,
Okay.
sir.
For this case, if you have the degree as even number, that is basically 8, and the coefficient is positive, that means if you are putting minus infinite here, minus
It's going to
infinite
be
to the power
infinite.
8, correct, and this is positive, then
Use
you'll have infinite as a
plus infinite.
plus infinite, correct. And for the
Yes.
end behavior also, for this case, as it is x to the power 8, so basically you'll be having infinite to the power 8.
It's
And
also goes to infinite.
okay, so basically it will be infinite, correct. Is this clear to everyone? So for this, our case, this is infinite to, it is going from infinite, so it is somewhat like it is coming like infinite and then going as infinite. Maybe in between there is something that we're not caring about now. We'll be caring about that after taking the considering the roots and all, but as of now it is starting from somewhere here. So at minus infinite the value is plus infinite, and at plus infinite also it is going to plus infinite, correct.
Yes,
So this
sir.
is coming like this, and then in between it is maybe crossing, touching, that we'll see, but it's coming from infinite to infinite. It's going from infinite to infinite. Is it clear to everyone?
Yes, sir.
Clear.
Yes, sir.
Okay.
Yes, sir.
Okay. Let's move to the next part. So after getting to know about the end behavior, so I'll just ask you about, not for this particular case, I'll just ask you all the conditions that can, what are the conditions that can happen. So I'll just write it out. If A is positive, and A is basically the coefficient of the maximum degree. Okay, I'm writing as a AN. Let's, for example, I'm writing AN less than 0. So for this case, the coefficient of the maximum degree is negative. Okay, for this case, the coefficient of the maximum degree or the degree for the polynomial is positive. Okay, not saying the maximum, but basically that is the maximum itself. Okay, so the coefficient of the degree, and this is the coefficient is also. So the possibility can occur is maybe the even degree, the multiplicity that you are adding is even, and or this is the odd. Okay, this is what can be possible, right? There can't be any other possibility, whether it's even or odd, or the coefficient is positive or negative. Okay, so now if I'm just putting x tends to infinite, what should be the value of the polynomial, the function, where the function will tend to
Infinity.
infinite, correct? And if I'm putting minus infinite also, the function will tend to
Infinite.
Minus
infinite, correct? Similarly, if we have tending to x to infinite, the function will tend to
Infinite.
infinite. If this is minus infinite, then the
Then
function will tend to
minus
Minus
infinite.
Minus
correct. And now the same condition, x to the power infinite. Now what should be the value?
Minus infinite.
Minus infinite. Similarly here, x to the power minus infinite, the
Minus
function will
Minus
be
infinite.
minus infinite. Here the function will be infinite. Sorry, the x is
Minus.
tending to infinite, the
Minus
function will be
infinite.
tend to minus infinite. And x is tending to minus infinite, the function will tend to
Infinite.
infinite. So these are the whole condition that you can get it on. If you want to take it as a screenshot, you can take it. But even though if you're not taking, you just have to use your basic knowledge that you are gaining, and you'll be able to go to the, like you'll be able to tell about the starting and the end here. What?
Sir, even this goes like quadratic, like if infinite to infinite, minus infinite to minus infinite.
Yeah. Okay. So these are the whole condition. Okay. Let's come to our problem that we are dealing with. So for our case, the degree is what? 8, right? So you can see that the best thing is you can just write it as what is the leading term. For our case, the leading term was something x to the power 8, and the coefficient was positive. So for us, x tends to infinite, function was tending to infinite. X tends to minus infinite, the function was tending to
Minus infinite.
plus infinite, right?
Oh, sorry. Yeah.
Okay. Now let's plot this. To plot this, let x and y coordinate. We have to plot this. Okay. So the only thing that we are knowing till now is from minus infinite to infinite, the function is starting from here and it is going till here. This is what we are knowing. Now let's come to the roots. So in between it will cross, touch the x-axis. That now the second step is to know about the how it is crossing and touching the plot. So the roots are 1, 3, minus 5, and minus 7. Let's mark the roots first. So this is minus 7. This is minus 5. And then you have 1 and 3. Correct? So the function is coming from here. It will for sure go here and then will go here because it is crossing or maybe touching the x-axis for sure. So it will come from here and has to go here. In between, it has to touch or cut the x-axis at minus 7, minus 5, 1, and 3. Now I'll have to see whether it's touching or cutting the x-axis. Okay, so there can be two possibilities. Whether it can just cross it all, this function can come it like this, or can go like this, or it can come like this and go like this. Is it clear to everyone or not?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now let's start. So for this case, and we'll just write the multiplicity also. What was the multiplicity for minus 7?
3.
3.
3. So 3. Basically, this is 3. For minus 5?
2.
2. For 1?
2. 2.
Or for 3, it was?
1. 1.
Okay. So let's start. So now the first thing that you should be knowing is, I'll just
Multiplicity
start-
is degree, right?
for each individual term, you can just think of as a, so let's, for example, for x minus 1, right? So for x minus 1, you can just think of as a x minus 1, right? This is 1. So for x minus 1, the root is 1, correct? And how many times the root 1 is occurring? So basically that is 2 times. Okay, if I told you in the quality equation also, if you have something like x minus 2 ka whole square, you have only one distinct root, that is 2.
Okay.
But how many times this is occurring? The repeated root is 2, like twice 2 is occurring. Okay, just for example, not writing twice, so minus 3. So this twice this root 3 is occurring. The distinct root is 1, but 3 is occurring twice. Okay, so if we ask about the roots, basically this is 1 comma 1. Okay, just because it's happening. So that is basically the multiplicity for each root.
Okay.
Okay. So now for sure this function will start from here, that you know, because from minus infinite we know that the starting behavior will start from infinite. Now it will cross, because the first root that is occurring is minus 7. So for sure this will come like this and it will cross minus 7. Whether it will cross or touch, we'll have to see the root multiplicity of the root. If
Whether
so, the
it's
best
even
is,
or odd.
correct. So whether it's an even or an odd. If this is an odd number, then what should be the possibility? It will cross or touch.
Cross x-axis.
Correct.
It
So whenever
crosses.
you are getting a odd, it will cross. Okay. And now how it is crossing, that you should not be knowing, whether it's crossing whether the graph is getting flattened or not. That you should not be knowing. I don't think so. They'll be asking you.
It's
It's
linear
just
or cubic. Yeah.
correct. That depends. If sharply it is crossing, then it's a linear, or if it's getting flattened and all, it can be cubic, maybe x to the power 5, 7, something like that. Okay, how flattened that is, that depends. That will tell you about the how big the value is, the odd value is. Okay, so the only thing that you should be knowing is, if this is an odd number, okay, then it is crossing the x-axis, and if this is an even number, then it's just touching or bouncing back. Okay,
Or bouncing.
Tangent.
correct. Now for this case, I'll just plot this. So it starts from here, then it will go here, correct? Because I told you it is odd number. So odd number it will cross. It will cross. It will start go like this. So it will start going like this. But then it will see that at minus 5 again I have to go back, right? Because minus 5 is the root. So I can't directly go like this. I'll have to go like this. But in between, it will see that minus 5 is again the root. So it has to go something like that. So the function will go like this, and then it will go to the minus 5, because minus 5 is also the root. For any polynomial, any equation, if you have a root, that will for sure have to touch the x-axis. So this basically is the minus 5 is the x-intercept. So it'll have to go to minus 5. So it will go there. But now it will see that the multiplicity is what? Multiplicity is even. So if this is even, it can't cross the x-axis. It will have to bounce back. It can't go like this. Okay, it will go. It can't go like this. It will have to bounce back like something like this. Is it clear to everyone? So it'll have to go bounce back, because it's an even number. It'll have to bounce. And again, the same, like, just you should be knowing even. Okay, it should not. You should not be aware of like whether it's 4, 6, or 8. How flattened is that? Okay, that you should not be knowing, and that is very difficult to know also. So now you just have to see is even. So if this is an even, it will somewhat like it will touch x-axis at minus 5 and it will come back. And again, it will start coming back like this. But in between, again, it will think that I'll have to go to minus 1 again, because 1 is again the x-intercept or the root of this polynomial. So I have to go 1. I'll have to go to 1, correct? If I'll have to go to 1, it will go something like this. And now again, it will see that what's the multiplicity of 1? Whether it's an odd, I have to cross this, or I have to come back, bounce back. So again, you'll see that at event. So what should it do? How should the function behave here? How will the function behave?
Bounce.
It will again bounce back. It will come like this. And again, it will think I have to go to minus 3. Okay? Because 3 is again the x-intercept or the root of the, or the zeros for this polynomial. It will go here. And now it will see that this is an odd number.
Yes,
Correct?
cross.
Then
Correct?
it's
So it will
Crosses
cross.
it.
It'll cross, and you already know that I have to go to infinite, correct? Because infinite, at infinite the function was infinite, so you'll have to go here, correct? So now you can see that this is the plot that you should be getting for this polynomial that has been given to us. Is this clear or not? Should I repeat it, or what should I? Clear to everyone?
Yes, sir.
So,
Yes, sir.
So as the multiplicity of 3 is 1 odd, so it is a linear, can be linear, right?
No, it
Yes,
can
yes.
be, yeah, it can be linear. So here it is like 1 1, it's a linear one basically.
Yeah.
Okay, so now this is how we should be plotting. So I'll just write whenever you are getting even, just bounce back. Okay, and then whenever you have odd, just cross. Okay.
Sir,
Yeah.
sir, that after 5, the line is like going around the axis or touching at any point after the 5.
It's
-5.
touching. It's touching -5 and then coming down directly. No, like it's just at -5. Nothing more, nothing less. So it's just going to -5 and then touching back. So this is -5 only. So only at -5, not in the neighborhood. It's just going to -5 and then coming back, bouncing back. Okay.
Okay, sir.
So whenever you have something like this, you have a quadratic equation, right? And you just have a quadratic equation somewhat like this, where x equals to 2. X equals to 2 is the repeated root. So it just touches and go, right? It doesn't worry about the neighborhood of 2. It's just coming at 2 and touching back, bouncing off. Okay. Here to everyone. Now can you tell me,
Yes.
so in this equation also, so the other thing that can be asked is, so the given for the given plot, now you'll have to tell me the number of turning points.
3.
How many times the function has turned back? Like it should have gone in some direction, but it has turned and then went to the different direction. Now you'll have to tell me the
Totally
number.
3, sir.
How many?
3.
3.
How many? 3 is not correct.
2, sir.
2 is not correct.
Sir, 2.
It's
3
5,
is also
sir.
not correct.
5
It's
is
5.
power
5,
5.
5, 5.
Yes.
Oh,
Okay.
yeah, yeah.
So it starts from here. The function starts from here. I told you how many times the function is turning back. Like it should have gone in some direction, but again after
2,
looking
sir.
at the roots or something else, it just turned back. So now you can see that the function started from here. It would have went like this, but now it has turned, right? So this is the first turning point.
Yes,
Correct?
yes.
Now again it has started like this. It should have gone like this, but now it has turned back. So this is the second.
Yes,
Correct?
yes.
Now again it has started like this. It should have gone like this, but it has turned again. So this is the third. Again it has started like this. This should have gone like this. So this is the 4 because it has turned again here. And again the 5th turning point because it should have gone like this, but it has turned and then it has started going like this. So it's the 5th turning point. Is it clear to everyone? The number of
Yes.
turnings altogether.
Yes, sir.
Yes, sir.
Okay. So this can be asked to you, the number of turning points. More or less. Okay, let's deal with some questions. Maybe that can help you. Okay, and one more thing that you should be knowing is, how does a function behave from in its domain? How the function behaves means whether the function is an increasing function or a decreasing function. Okay, the basic see from this function I can tell you the function from minus infinite till -7, whether the value of the function is increasing or decreasing.
Decreasing.
It is on the decreasing line or an increasing line? Decreasing, right?
Decreasing.
Basically, it is strictly decreasing, but even though you don't have to worry about it strictly, that what particular strictly, because it will be taught about those in the coming week. But what should we expect to know? Because in the exam, they can ask you, they can give you the plot and they can ask you the increasing and decreasing. They'll not be asking strictly, or those minute point they'll not be asking, but they can ask you the strictly whether the function is decreasing or increasing. So from minus infinite till -7. So from minus infinite till -7, the function is decreasing. Okay, they'll not be asking you from -5 to -7 because you don't know about where the function is having a minimum or a maximum. Correct? But again, they can ask you from 3 to infinite, the function again is increasing or decreasing?
Increasing.
Increasing.
Correct. So from -5 to 1, they can ask you like first it has decreased and then it has started increasing. In this way, they can ask you. Maybe from
Hello,
1 to 3 also, it has first decreased and then increased. Yeah.
Hello,
If somebody asks. Yeah.
Yeah. So why can't we tell what happens between -7 and -5?
-7 and -5. You can tell like the function first decreases and then increases. This you can tell, but mostly they'll not be asking whether what's the point where the function is, like from -7 to which point the function is decreasing. This
No, but
I don't think so.
I get that. Just like you mentioned something about the minima and the maxima. So I just want to understand what makes why did you generalize the idea that you can't exactly tell what happens there?
No, you can tell, but I'm saying that they'll not be asking. The exam, the qualified will not be asking because that has not been taught. You can get the value, but yeah, I'm asking that if they're asking because there's a minimum thing that I can ask you is how the function is behaving in its domain. The increasing and decreasing, that's it. If you just go through the previous some paper also, they'll not be asking where the function is getting minimized. Okay, because they not have taught for the bigger polynomial. They have taught for the quadratic. For the quadratic, they'll be asking you, but they'll not be asking for the bigger polynomial. What's the vertex? At which point is getting a minima, global minima, or the local minima. Those type of things they'll not be asking. They can ask you what's the number of a local minima or the global, like the number of the minima only. Okay, they can ask you that. So how many minima are there? 1, 2, and 3. 3 minima are there. That they can ask you. What's the number of minima? Okay, they'll not be asking global or a maximum, local and all. They can directly ask you. Even though they're asking local, you'll have to write it as 3 only. So those type of things they can ask you. Okay, so my point was they'll not be asking the point where it is getting minima or the critical points where it is getting minima or maximum. That will not be asking. Okay. Okay, is this clear? So the number of turning points they can ask you, and then they can ask you whether how is the function behaving, increasing or decreasing in some particular domain. Okay, and then they can ask you about the number of global minima and maxima. Okay, I'll just give you one question. Try it out, and then I'll just write the.
Can you explain the domain part again?
Okay, so what I was saying is, then ask you something like, how does the function behave in its domain? So for this polynomial, can you tell me what's the domain for this polynomial? Is it R to R or something else? Is R to R, right?
Yes, sir.
Yeah, because you can see that the value, the domain is from minus infinite to infinite, and the starting behavior also. So in the leading term, we have checked that, right? For x equals to minus infinite is going till plus infinite, right? And similarly for here also, from minus infinite is going to minus plus infinite, correct?
Yes, sir.
Right? So the domain, so that you can take any values from minus infinite to infinite, correct? Right? So here the domain part is clear, but they can ask you in the domain itself from minus infinite to -7, how does the function behave, whether it's increasing or a decreasing. The statement can be from minus infinite to 7, the function is increasing, the function is decreasing. Those type of equations they can ask you, and then you have to answer those. Okay, this is pretty simple, right? Because without plotting this, you can't tell. So that is what my concern is. You have to plot that. If you're just giving you the polynomial, and then they are asking you something, so you'll have to plot that function, and then only you'll be able to know, correct, whether it's increasing or a decreasing. So for this polynomial itself, they can ask you the polynomial given. For the given polynomial, the function is increasing from this value. Even though without plotting also, you'll be able to solve by putting the values, some random values between maybe -8 will be putting, or maybe -15 will be putting, and then we'll be just checking the values, how does the function behave. Because if you're just taking out, because you can see that minus infinite, the first truth that you are getting is -7. So the behavior from minus infinite to -7 will be same if you're just able to know that at 2 point how does the function is. Like maybe you can just check it out as -15, something like that, and -7 and minus infinite. Maybe minus infinite and -7. Just check the values and how does the function. At -7, the function is 0, and at minus infinity, the function is positive infinite. So from positive infinite, it's going to 0. So that means the function is decreasing. But if let's for example, they're asking you from -7 to -5, the function first decreased and then increased. For those cases, you'll have to plot. So the best thing is to plot the graph and then get to know about how does the function behave in its domain. At least the increasing and decreasing part. This is what I'm saying. Is this clear to you? Or
yes, sir, it is.
Okay. So let's deal with one example.
It's odd function, sir. Odd polynomial.
Okay, so you have given this. Now you have to tell me. Okay, so now you'll have to tell me from minus infinite to minus 1, the function is decreasing or increasing?
Increasing.
Increasing.
Increasing. From 2 to infinite, it is increasing, correct? Yeah.
Yes.
Now the second thing that I'm asking, how does the function behave? As x tends to infinite, what is the function value? And at x tends to minus infinite, what is the function value?
Minus infinite to
Infinite is plus and x tends to minus infinity is
Minus infinite, correct? So this type of questions can be asked. Then the other thing that I can ask you, the multiplicity of minus 1 and 1 must be same. What do you think?
yes.
X is equal
Must.
to 0.
Yes,
No,
sir.
I'm just asking the statement, I'm writing it. The multiplicity of minus 1 and 1 must be same. So the word must, you should have to
Maybe
consider.
same, sir. Must be not.
No.
Yeah. If this is like
Maybe it
can
may not be.
if this is can be, then this is correct, right? If this is
Correct,
like
yeah.
must you can't say, because how flattened that is, you can't say about that. Like from the plot, it's very difficult. So if they are anywhere, it's just asking must word, because this is like very extreme word. It's like an incorrect option. So if they are asking can be correct, then it's okay. Now can you tell me what should be the value? Like, is it odd or even?
Odd.
Odd.
Even.
Odd.
This is odd.
Odd.
This is odd.
Even.
Okay. Now, if they're asking what can be the degree for this polynomial, what
First
can
one.
be the degree for the polynomial, whether it's an odd or an even number? So, even this polynomial has a degree as an even number or odd?
Odd number.
And now, if they're asking what can be the minimum degree for this polynomial, what do you think?
2.
Minimum degree for this polynomial?
3.
3. How would you? So minimum. So the minimum degree that you can think of as a. So first of all, we'll be taking odd. So the minimum number odd, you can take it as 1. Here also 1 1. So 3, and for the even number, we'll be taking at least a 2, right? So you'll have a minimum of 5, right? The degree is 5, correct? If you're just taking even minimum even, like you don't have to take 0 as an even number as of now. Okay. So have a minimum. So if they're asking the given plot, the minimum degree that can occur is what? The odd, it can be like, it is basically the odd, because 3 odd and 1 even. So I'll be having what should be the value you should be getting if you're just adding odd, even, odd. So
5.
it should be an odd number. It is an odd number. Correct? Is it clear to everyone?
So could you please explain the last two questions that you explained the degree of the whole polynomial and this one?
Okay. So what I was saying is, so you can be given the polynomial, the graph can be given to you, and then they can ask you whether the degree for the polynomial given, where the graph has been plotted, is it even or an odd number? Okay. So for that case, you'll have to check the multiplicity for each of the roots. Okay. Now you can see that for minus 1, as it is crossing, for sure it will be odd. For 0, it is touching and bouncing by, it will be even. For 1, it is crossing, so it will be odd. And for 2, it will crossing, so it will be odd. Okay. So basically, you'll have to add 4 numbers, because the multiplicity is just add it and get the degree for the polynomial, right? So for this case, it is odd, even, odd, odd. So if you are just adding 2 odd numbers, basically you'll get a even. So basically this is even plus even, but at the end you are just again adding an odd number. So the degree for this polynomial would be an odd number. Is it clear? And take it as example. So odd number, let's take it as 3, this 4, this 3, and this 3 again. So 3, 3, 6, and then 4 is 10, plus 3 is 13. So you're getting a odd number as a degree, correct?
Yes, sir.
Okay. Now the second question that I'm asking, what can be the minimum value for that like the degree for this polynomial? Minimum number I'm asking. So as you know that this is odd, even, odd. So minimum odd number that is possible is 1, right? Similarly, minimum here also is 1, here also it is 1. So 1 plus 1 plus 1 is 3, but 1 odd is there. So minimum that is 2, right? So left with 3 plus 2 as 5. So minimum degree for this polynomial is 5. Is it clear or not?
Yes, sir.
Okay. Now the next question that I can ask you is, what is the number of turning point for this polynomial? Can you tell me the number of turning points?
1, 2, 3, 4, 4,
Four. Correct. So you can see that started like this, it goes like this, but it wants to go like this one. So the first turning point is here. Now it started going. So the first turning point is here. Now it started going, but it'll have to turn back. So second is here. Again it has to turn back. So third, and it will go again. It has to turn. So fourth is here, right? So the four turning point: 1, 2, 3, and 4 turning point. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay. I hope, yeah, so this is done. Let's solve one more problem, and that will be the last problem. I guess the polynomial, everything we have dealt with, will take your doubts also, but let's solve one more problem. Okay. Okay, let's solve this. So if you have questions like this, -1, this is the polynomial that has been given to you. Okay, now you have to tell me, first of all, the px tends to 0, what should, so not px tends to 0, x tends to, now first of all tell me, I'll have to tell the number of distinct root.
4.
Okay, the first thing is this one. The second thing that you have to tell me is the number of turning point. That thing is x tends to infinite, px is tending to what? X tends to minus infinite, px is tending to what? Px is the odd polynomial, or px is a even, or even or odd, that you have to tell me.
odd.
Okay, so let's start with the first question. So what's the number of the distinct roots?
4, sir.
4 rows.
Okay, so here, here you are getting 1 as -1, right? Here
Plus
you are
1
getting
minus
1 as
4, 3.
4. Here what you are getting?
3.
3.
3.
Okay, so the distinct, how many distinct roots are there?
5.
4 distinct roots.
4 distinct.
1, 2, 3, 4, right?
Yes, sir.
5,
Yes, sir.
how 5, 4 only, right? Correct?
Yes.
Yes.
Okay. So 4. So for this equation, now number of turning points. For the turning point, we'll have to plot the graph. Okay, that we'll have to do as a homework or assignment. Okay, that you'll have to do. Okay, as a
3.
turning point, you'll have to plot. Okay, whatever the value it is, you can just plot it off and then get. I don't know the number of the exact turning point, but this you'll have to do as a homework. Okay, at assignment. Okay, that is fine. I am not. Okay, so now you'll have to tell me the value of x tends to infinite. What should be the value of the function?
Minus infinite.
X tends to infinite. The value is tending to minus infinite.
No, sir. Infinite.
It's infinite.
Okay, it will be infinite, right? It will be like the coefficient is positive. If the coefficient is positive, even though the number is odd or even, that doesn't matter. If you are tending to infinite and the coefficient itself is positive, that means it will be positive. And if you have a minus infinite, then what should be the value?
Minus infinite.
Minus infinite is minus infinite, and you can see that the coefficient is positive, but this is an odd polynomial, so we'll be having a minus infinite. And here I already told you it's an odd polynomial, so we'll be left with only odd polynomial. Is it clear to everyone?
Yes.
Yes, sir.
So the odd polynomial part.
It is a even polynomial or odd polynomial.
Yes, okay.
So you can see that the degree, what's the degree for this? X square, right? Correct. And here also the is this x and this is x square. If you just multiply this x square,
Odd,
x and x square, you'll be left with x to the power 5, correct? And this is odd, right?
Yes,
So
okay.
for each term, you just take out the maximum degree. So here it is x square, or you can just write it as x minus 1 or x plus 1. But here also you'll have to multiply x square, and again you'll have to multiply x to x cube, and again x square, so x to the power 5. So x to the power 5 is basically the odd polynomial. So this is pretty simple, right? Even though from the multiplicity also you can just mark it as, so for this, for 1 the multiplicity is 1, for minus 1 the multiplicity is 1, and again for 4 multiplicity is 1, and for 3 the multiplicity is 2. So 2 plus 1 plus 1 plus 1, basically 5. So if you have the multiplicity as 5, that is basically the odd polynomial. Okay, is it okay? And for if you are just for increasing and decreasing function, I'll just write it the definition. Maybe if you can just, it's important because they'll be asking you for sure in the exam. Okay, for the from the given plot itself, they'll ask you it's an increasing function or a decreasing function. Okay, for any function fx, a tends to be a function where xi, x1, x2 belongs to a, that is in the domain, such that x1 is less than equals to x2. That is basically the, if this is leading, like if x1 is less than equals to x2, the function is x1, the function value at x1, okay, will be less than equals to fx2. So for the increasing function, however the x and y is behaving, like if x1 for a given polynomial, right, for any function. So my pencil got down, so I can't write it from now, but okay, I'll just tell you, this was the, even though this was the last, okay, somehow I'm able to write it, but it'll get blink. It is blinking, so it'll be down. So for this case itself, we can just think that for any one, okay. Okay, so okay, I'll just tell you, you can just think of, like, even though we have already discussed about the increasing function, the only thing that I was saying was increasing function, and whenever you have written strictly increasing, that's a two, it's like almost similar but not the same. For increasing function, for some interval the value can be same. We can see that x1 is less than equals to x2, so there can be some interval where the x1 and x2 are different but the function value is same. Okay, but it can't decrease. Are you able to understand this? Are you able to hear me?
Yes, we are.
Okay.
Yes,
So
sir.
what I'm trying to say is, for an increasing function, for any two values in the domain x1 and x2, okay, if x1 is less than equals to x2, okay, so for any function x1 less than equals to x2, the function value will also behave in the same way. fx1 will be less than equals to fx2. The only difference between the increasing function and the strictly increasing is, for the increasing function, the function can be something like, it will be increasing values, the values will be increasing, but for some interval it will be same, the value will be same. For let's, for example, x1 can be, so x1 can be 3 and x2 can be 5. So 3 and 5, those are the two different numbers, but the function value f of 3 and f of 5 can be equal. So it is increasing. Basically, it is increasing. Let's, for example, from minus infinite it is increasing, but from some interval from 3 to 5, it was same. The values were same, and then again it is increasing. So basically, it is not decreasing at any particular point, but for some interval it is same. The values of the y is same. Okay, and this, the difference between this increasing and the strictly increasing is, for the strictly increasing, this equal to sign won't be there. So for x1 less than equals to x2, fx1 will always be less than equals to fx2. Okay, so there won't be any interval where the function value will be equal. Okay, I'll just discuss this concept again in the next class, but because I can't write it. Okay, so because the pencil, I don't know how, because basically it's like it was not charged, I guess. Yeah. Are you able to understand this? Are you able to understand this or not?
Yes, sir.
Yes, sir.
Not completely, but yes, somewhat.
Okay, I'll discuss this concept again in the next Sunday, and then we'll take your all your doubts. So just go and solve out the activity and practice question. Maybe the graded also. We'll just discuss all those concepts, not the graded, but activity and practice we'll discuss on the Sunday night, like whenever the session. I guess the 8th is the next session. Sorry, I guess 29th is the next session. 29.
So will there be mock exams released on the?
That will be released. Yeah, that will be released maybe next week. Upcoming Monday will be released.
Okay.
So mock, and then there will be discussion regarding the mock also, and there
Okay.
will be 3 more sessions where we'll just solve the problems, and that will benefit everyone.
Sir,
That will make you prepare for the qualifier. Yeah.
where you are uploaded this PDF, sir?
So this PDFs will be there in the supplementary content. All the sessions that I have taken, maybe I don't know whether they have uploaded it or not, but date wise it will be there.
Yes.
Whichever the session that I have taken. Okay. In the supplementary content, there will be options of live session slides, and there you can find it. If you're not able to, just ping me in the Discord or somewhere. I'll just make the team remember. Like I'll just remind them also to upload the files. Okay.
That discourse is only for the students, those who have entered through JEE.
Yes, so we don't have this course.
Okay. Okay.
Sir, you
Okay,
can
then,
better one thing, you can just save it in your folder and then share it in the chat box. Then we would be able to download it.
correct. So I'll do that first. I'll just check, because if I'll just upload it there, everyone will be able to check it, right? If I'll just upload it here, only the people who are available here will be able to see the files, right?
No,
I'll
sir,
just
we will share it. We will share it. There are many such groups where
no problem.
such
No problem. I'll try to upload on the portal itself. I'll if it not will be uploaded, I'll share in the next session. Okay. So don't worry. I'll
Yes, so
just
that's
try
all
to
right.
in the
We'll let you
portal
know
it
in
will
the
be
next
there first.
session.
Before the next session, for sure it will be there in the portal, whatever the session that I've taken. Is it
Yes,
clear
sir,
to
yes.
everyone? Okay, so I'll just drop it off because I don't have anything to write it out. Okay, so maybe in the next session, 4th week is done totally. We have just discussed all the concepts that are there in the lectures, or that can be asked in your qualifier. Okay, whatever the question that I have discussed, 3-4 questions, that will suffice you to solve the problem that has been given in the exam. But even though you practice more questions, you just have to go through the activity, practice, and solve all the problems. We'll discuss whatever the doubt we have that you have on the Sunday session. I guess that is on the day after. Today is Friday, so day after tomorrow. Okay, is it fine to everyone?
Excuse me, sir.
Yes,
Sir,
sir.
can I ask you a conceptual question from week
Yeah,
3?
yeah,
It's nothing to
yeah.
solve of.
Okay, go ahead.
Sir, I'm posting it in the chat to you. Sir, actually, I wasn't able to join the Wednesday live session, unfortunately, in
No
which you
problem.
explained this question. This bike stunt one. Sir, actually, the day before, one day earlier, I asked the same question to, I guess, Samriddha ma'am, and she explained it in the way, she explained it through the trigonometry identity, like tan theta is equals to P by B, that one formula. And I also solved this question by that method only, but I'm getting answer 5, and she was also getting the answer 5. But you solved this question, I saw the recorded session, you solved this question through quadratic equation. Sir, so I want to know that where I am going wrong.
Okay, so because I didn't use any because see this question, I don't know how did you solve, but it's just the same. Like you just have to calculate the vertex, and if you're able to calculate the vertex, basically you'll have to take the axis of symmetry and then multiply with 2 to get the exact distance. But I don't know how did like you tried it. So maybe the method I'll have to check. You can just you can tell like method. How did you approach? You can just tell me, or maybe you can just send me
Yes,
the
sir.
screenshot that how did you approach, and then we can discuss it out. Whether it's like where I am going wrong or where you are going wrong. Okay.
Sir, can I tell you like right now?
Okay, so okay, but I
Sir,
can't write it.
actually,
The issue, yeah, I can't write it, but you can just tell me. Even though the best thing is you can just send me this, like you can just write it out and send me the solution. This can be the best thing, and then
sir,
I'll
actually
let
I'm
you.
using the laptop now, so how can I just get the photo of it? Okay, sir, I will try.
No,
Sir,
later also you can send me, but okay, even though you just tell me how did you approach, maybe.
sir, actually I assume that a perpendicular line through the vertex is joining the I draw imaginary line which is passing through the vertex which is perpendicular. So that vertex point and this A point and like mid of this A and B.
Okay.
So I took that triangle, and for that triangle we have theta, And for that, tan theta is given to us equal to 1. For tan
So
theta
one
is
second, one
being,
second. So the theta that has been given is how it started in this initial part, right? It started with 45 degree,
yes, sir.
correct? Started
Yes, sir.
45 degree, and now you're saying that you just took it. So you just from the vertex you dropped a perpendicular line, correct?
Yes, sir.
This is what you're
Yes, sir.
saying, and
Yes,
from the
sir.
vertex you have perpendicular line, and then you just okay. So you just directly converted this theta. Okay, you started solving the method. I don't know whether it's a okay. That can be correct. But how did you know that whether the point that after dropping from the vertex to in between A and B, that's the middle point? How did you know that?
Sir, because if we draw a perpendicular line through vertex, which is basically axis of symmetry only, so both the sides are
Okay,
equal.
got it, got it, got it. Okay, so that's correct. So from there you have dropped it from the vertex, and then you were saying that that's the middle point, and then you just take it. Okay, got it. And then that's a mistake that you're doing. You just took it directly as a 2.5, whatever the height was there, and then because it's a 45 degree, you're just taking that as a 2.5 and 2.5, and then you're saying that it's a 5 feet. This is how you solve.
Yes, sir. Yes, sir. Yes, sir.
Okay, but the issue is, so the theta that has been given is not the theta to that like it's not the theta that it's making to the like the highest point. Are you getting me? Like this, the theta is just the initial the slope of the starting parabola, but it's not saying you that this the 45 degree it is making to the highest point.
Okay, sir.
So the assumption that you have made is that from the from the highest point also, this is the same theta, like the 45 degree only it's making. This is what you have assumed, I guess. Correct?
Okay, sir. Yes, sir.
I guess that is the incorrect assumption that you are making. Because
So
if
will you
there
be
are
able to
different,
discuss this properly? Because even I want to have my doubts cleared on this. So like when
okay,
you get to write it properly, that's something. Maybe in the next
okay. Maybe in the next session we'll discuss this question again. Maybe
Okay,
maybe
so
that can be.
basically,
Yeah, go ahead.
you want to say that we can't assume it to be right angle triangle, right?
No, it can be right angle triangle. I'm not saying that it's not a right angle triangle. I'm saying that the 45 degree that you are assuming that from the initial point to the highest point that you are assuming that's a 45 degree right. So it's like a foot at the 45 degree only. This is what your assumption is, correct? So from this point of the peak, the vertex that you are saying, from the peak to this initial point, it's making the 45 degree only, correct? Then only you
Okay,
are
sir.
able to equate the what the base and the perpendicular value, correct? And then you are saying that the base is 2.5. Similarly, the base will be from the other house also, it will be same. So 2.5 plus 2.5 is 5. You're not using any of the concept of the, I guess, the quality equation, any like the parabola. You're not using any of the concept. This is how you have
Yes,
solved,
sir.
correct? I
Yes, sir.
get the
Yes, sir.
assumption is incorrect, but even though I'll just write it, maybe that can be a correct assumption, but I'll have to check it. Like we'll solve it and then we'll be able to tell you the correct way, because I can't
Okay,
write
sir.
it now. Otherwise, I would have
Yes.
solved it.
No issue, sir. Thank you, sir.
But I guess
So
the
it will,
assumption is incorrect that you're making from the vertex, like because see, even though let's for example, I'm just giving you one example why your assumption can be incorrect. So
Yes,
let's
sir.
for example, this B is very far from this A, okay, and the and this has started like from here. The stuntman has started with 45, like maybe for some 45 degree only. So every time, whatever the circumstances is, your distance will always be like constant, right? Are you getting me? From A to B, it will always be same,
Yes, sir.
correct or not? So there must be
Yes, sir.
some mistake that you're doing, because even though the height like A and B can be very far, and then you're just assuming it started from A as a 45 degree only, okay, and
Yes,
it's
sir.
dropping here at 140 like 135 degree. Every time your value will be 5 feet only. The distance between two heights will always be 5 feet.
Yes, sir.
So I guess that
no, but why are
Sir,
we
Uh,
assuming 45
okay.
degree here? I just want to know.
What 40, because it's a tan theta is equals to 1, so that's why it's 45.
Sir,
Acha,
for
yeah,
sir, even for that, actually, I'm not assuming that it is 45 degree, but according to right angle triangle only, if I'm drawing a perpendicular, so
Uh-huh.
it is 90 degree. Tan theta is equals to 1, theta is 45 degree. So automatically the vertex angle, the angle between our vertex and this parabolic path, that is 45 degree only according to angles and
That's the
property of
average.
triangles.
That's the average slope, not the instantaneous slope.
Yeah, correct. That's the
That's the
instantaneous like value that has been given, theta as a 45 degree. So, but you are just what you are doing is from the like vertex from the peak point, you're just adding that straight line and then you are saying that it's a 45 degree. The assumption that you
Yes.
are making.
Okay, sir.
Here the theta is instantaneous. Like at the 0, 0, they have given just that started with 45 degree. If
Yes,
they would
sir.
have given something like it's making a 45 degree angle with the peak point, then your the method that you have solved is correct. But it's not given that theta that is making with the peak point. Okay, so this method can work wherever the angle has been given. So maybe you would have solved some of the problems where it started with some house like with some height and then they have given some theta with the peak value, like maybe the torch problem or maybe the ray problem. I guess this is how we used to solve in class 10th or 9th, right? So the theta they have given, and then you have to use the basic concept of the sine theta or cos theta or maybe the tan theta, and you'll be able to solve it. But even though I'll discuss this again, okay? No problem in that.
See, in this
Okay, sir.
polynomial
Understood.
session today,
Okay.
so we have come across many equations and problems. So I can able to relate this kind of real life examples to the quadratic equation, so you can come across a solution for this kind of problem. And the linear equation, you can come across real life problem such as like getting the distance of x to y. So it is a linear. So what are the impacts of this polynomial to the polynomial equations for real life examples, and where it gets impact or real life? So quadratic somehow I can able to relate into the real life. So today's session I'm talking about
the stock market.
Stock market or many places, like it's not always a linear or some form of a quadratic always. So stock market is the best example. Or maybe for the stock market too, you can't even be able to get the polynomial itself. Like how does for any stock, like basically that's the time series data. But for any problem, you'll not be having the equation in the form of a regression or in the form of a quadratic. Your values will vary a lot in the
But
form
sir,
of
the
some
growth of a
polynomial.
company could be also equated, right?
Correct. The growth of a company. Yeah, correct. There can be the variable, whatever the feature that you are assuming. The feature can be dependent in the form of some degree 4, 5, 6, something like that. Not be always be.
So maybe, so this, if you could agree or just disagree to what I'm trying to say. So if it is like, let's say, a performance of a company, and the variables are maybe X, Y, Z, which could be raw materials or time taken X, Y, Z, and then the graph is plotted on such inputs to get whatever output we get, right? And that is a graph.
Correct. Yeah, that's a good example, like where you can have n number of features and then the polynomial, like it's dependent on n features of that features can be raw material or there are some other things also.
Or to simplify it, maybe it is something about a classroom where like, the performance of a student depends on X, Y, Z factors or something like that.
Correct. So it's not like, even though that's not in the single variable, and because there can be multiple features for any, and then that can be in the form of some different degree of a polynomial. Okay, so in normal life, you'll not be having very simple regression or a quadratic form of equation where there can be one example like how is the weight dependent on the height. That can be a linear thing, but that is pretty like that also is not always linear. But yeah, you can think of as a linear, but normal life will not be having. You'll have to go and decide something. Will have a n number of features. Okay, so there the polynomial comes and help you.
Okay, thank you.
Yeah. So I guess this is done. But okay, even though we'll meet again in the Sunday 8 to 10 and we'll discuss the doubts that you have from the 4th week or maybe the other doubts that we'll be having. For the next session, we'll be having continue, I guess, 3-4 sessions, and then upcoming weeks, just to make you prepare for the qualified, and that's it. Okay. So what are I'll just try to make you one request is to attend those sessions at least, the last 3-4 sessions that we'll be going through. We'll be solving some n number of problems, and that if you are just attending those sessions, I can assure you that you'll be able to perform nice in the qualify exam, at least for the maths one. I can't say for the other courses, but for maths one, I'll make you prepare for the qualifier with some examples. Okay.
So it's on Saturday, right? Sunday.
Sunday is for the 4th week, and after that we'll be having some 2-3 more sessions in the next week. So before 7th, we'll be having minimum 3 to 4 sessions. So that will be helpful. Okay.
Okay. Thank you, sir.
Okay. Thanks everyone for joining the session. Okay. Have a good
Thank
day.
you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thanks everyone. Bye.
Thank you, sir. Have a nice day.
Okay. Same to you, everyone. Have a nice day.
Thank you, sir.
Thanks.
Sir, I just sent my solution
Bye,
of that
sir.
question.
Okay, I'll just check it. I'll just download it so that where is that solution for which question? Okay, for this question. Oh, yeah, this is correct. Yeah, this is correct. I guess Jay, right? Jay, whatever you have sent is correct.
Yes, sir. And my answer is 10.
Yeah, 10 only. So I was also, but I'll just check it with how she has solved with the theta. Maybe that can be correct and ours can be incorrect. But even though I'll just check. But as of now, I think so. Whatever we have done is correct. Okay. Thanks for